I'm gonna go for it.
Yeah, more people like Joe coming
They'll just drift in. Okay. So my name's Biying, and I'm one of the co-founders at Hot Factory. We're a lot of things, and I'm sure a lot of you guys wear different hats too. But I started out in architecture school, so I'm at core a designer. But since then, we've started the company to do our own product. We've offered consulting services, and right now, primarily, we're a little bit obsessed with any kind of robotic equipment that can help us make things. So what we have at our shop are 3D printers, we operate laser cutters, and we also operate CNC mills. So looking at this trifecta, I call it, of robotic equipment, we're able to help all kinds of different people make their ideas real. Now, it's different scales, so something as small as a part for, an engineer in like a piece of medical equipment, and as large as like a building and mock-ups for buildings. And we build marketing experiences. We work with fashion designers and industrial designers and architects. So it really ranges. And you'll probably find that I'm mostly talking about a tool set, not about any particular application. But it just so happens that a lot of the people we work with are designers, and I think there's quite a few of you here. So I can speak to that specifically. I'm also going to be talking about how we used all those robots to start our own small business. And at this point, it is a successful small business that has been completely bootstrapped with no investment. So we didn't take on any capital, nor did I invest very much capital of my own. So I was just like you guys when we started.
Yes.
So I'll tell you a little bit about that, okay?
Yes.
So yeah, we're Hot Factory if you want to tweet or if you want to follow us on all the channels. Instagram has all kinds of photos of the things that we're working on right now, so you can have a scroll through that. So I'll start with just where it began for me, and that was in architecture school. And the city that kind of I start my story in is actually Rome. Have any of you guys been there?
Been there.
Driven.
Wow.
Why did you
Nothing
stop?
worth stopping for.
Okay, so the cool thing about Rome that I found when I was there was it was this melting pot of the past, and that's very, very, very old history, but this kind of collision with a modern city. It's a metropolis, and there's lots of cool things happening there. So I thought it was this interesting intersection of the past and the future, which also had a lot to do with the ideas that I was having at the time, studying a traditional design form, sketching by hand a lot of times, but then like learning all of these new digital tools like Rhino and learning how to code. All of those things kind of collided for me when we were studying in Rome for a semester. And we did a project to actually figure out a kind of museum of sorts in one site in the city. And this site was also a collision of many, many different aspects of a city. And when I came to design a building, for some reason, I wanted to build a robot instead. I don't know if you guys have heard of this. It's called responsive architecture. It's buildings that are made out of sensors and robotic parts. So being like wild and rebellious in my school years, we decided, hey, like maybe a building doesn't even have to look at a building, look like a building. And if people are streaming in and out of the cities with their phones turned on and all kinds of information being dynamically kind of, swirling around, maybe our environments can be just as agile as like our digital lives. Yeah. When you open your Facebook and like you see your own curated list, your music, your clothes, everything is curated, but the buildings we're in just feels like it's really lagging behind, 4 walls, come on. So this idea is, okay, well, if buildings were also responsive, then maybe they can respond to the sunlight. Maybe when there's lots of light, our windows are clear, and maybe when it's really sunny, they become opaque and filter some of that light out. That technology exists. Maybe our facades, instead of being just like stucco or metal panels, maybe they're breathable. Maybe they can open and close. So really, in that sense, maybe there's no windows. Maybe there's just breathable walls in general. So at the time, I was just kind of experimenting, and all of our profs were like, "What are you doing? Like, this isn't architecture. We hate it." So while it didn't go very far academically for me, it was just kind of experimental. At the time, though, I knew that there was something there. And it was called rapid prototyping. I was using it a lot when we were building models of things, mocking things up. You use 3D printers and laser cutters and CNCs to make things really fast. And at the time, it was for creating ideas and iterating through different thoughts. And at the time, we were using a lot of computational design as well.
Sorry, what's a CNC machine?
Okay, so I'm going to show you a video of it later and you can see it. It's another kind of robot that can basically sculpt any kind of material for you. I'll show you in a little bit and then you'll know.
It's really cool.
So computational design, do you guys hear that buzzword a lot? What it really means is that instead of designing like traditionally, like by hand, sketching out the left and the right and the front and the top, designing in 3D is one thing, but also design using parameters is another. It's kind of like coding design, which is more parameter based, so you'll hear words like parametric design a lot. But basically it's using computers.
Yeah, I want to hear what you
Isn't Grasshopper-
to ask and you comment on.
Are you doing that in Grasshopper with Rhino?
Yes, I am. Okay. So like, there are two different concepts, rapid prototyping, which is computers and robots that do things for you, and then you're also designing using computer language. Those two can obviously come together, right? So I was thinking, okay, well, if I design using computer language and that hooks right into equipment that will make it for me, it really empowers me as a designer. Like before we used to draw things and then we'd have to show it to a contractor, or we'd have to show it to the brick guy, or like call this guy, print it for me, whatever. And you kind of like don't get to do a lot of that, and lots of capital is right in between that entire thing, so you can't make the idea you have real very quickly or very inexpensively. So I think these two things coming together really enable people to do things faster, and I'm calling it digital manufacturing. It's going to be the opposite of mass manufacturing. It means that things can be designed one by one, things can be customized, and the designer will have a lot of control over the actual making of something. Traditionally, everything is mass manufactured, you know, like by the time someone designs something, they gotta get a mold made and they have to make 100,000 units before any customer can even see it. So with digital manufacturing and the technology I was talking about before, you can make things one at a time. You can test things out and change it. You know, it could be just as agile as software development. So I think designers of physical things are going to start having a lot more power, just like the software designer had, like in the last decade. You saw those software companies come out like overnight. They could just like make $1 billion overnight. I think that's not really happening so much anymore, but there's gonna be a new wave of that kind of model, because someone can, like a designer can physically, rapidly make things happen. So that means you can have that startup mentality now with manufactured goods. So putting all of that together, well, I think I just told you why you should care. So yeah, you should care about this if you guys are, you know, even remotely interested in making things. And then I was talking about, you know, this mass customization thing. It's like where all of our focus is right now. So not only is there this connection between the designer and actually making it real, I think even bigger than that, there's the opportunity for consumers to be way closer to the manufacturing process. Because once everything is computerized, it could easily live on the web. And since we're all
On the internet.
on the internet, you can give that like feeling of being a designer to someone who isn't. So I think that's really cool. And I'm thinking that it could be very, very real, like very soon. A lot of companies are doing this already. Products that can be customized by the user, and then it gets shipped to you like in 3 days. So this is stuff that I think the digital manufacturing, the rapid prototyping, but then like the power of the internet is going to help us all kind of do this to get something interesting made that's not like 1 out of a trillion made overseas, you know? So, so the first reason, I'm just kind of breaking it down here, like why is it so great, you know? The first thing that I think of when I like became a designer was the magical feeling of seeing something that you thought of become real. Like, have you guys experienced that yet with something that you thought about? It's really awesome. Like, it took me a while to have that experience because architecture is slow. Like, you know, buildings take years to actually come to life. I think I worked on like a project when I was an intern, like going to school during one of my co-ops, and probably like 4 years ago, one of my colleagues emailed me a picture of that building constructed. And I was like a kid, I was like 19, and I think my job was to design a pattern that was going to be like the frit pattern on a window. That was it, and it was like a stadium project. I had this tiny little thing to do during my summer. And he sent me a photo of my frit pattern on a window, and it's huge too. So I was like, whoa, this is great. Like, you know, I'm like, it's 5 years down the road, and then I'm finally feeling this magical feeling. And it was so funny because like they printed or like made exactly what me, 19, me, designed. I didn't do anything. I was like, okay, just dot, 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 dot. This dot is denser, this dot is less dense. Done, hand it in. But they did it, like they built exactly what I drew, which was so cool, and I thought that was so magical. And if you've ever crafted or life hacked or done DIY projects, I think people know what that feeling is like. It's really, really nice. I love it. And the second time I felt it was with my partner Matt. So he was working at this huge corporate firm called Cutting and CNC Machining, and he was lucky enough to work on a cool project rather than a boring one. So he was actually a part of this. Oh, this is so dim here. Oh, okay. It's fine. He was a part of the stadium project where they were designing this like swooshy type of facade. So I think because there was this good budget on this project, the team actually designed the facade in Rhino. So like for a big corporate firm to try this on was not like, it doesn't come by often. But basically you can see here like a screenshot of something being designed in Rhino with a Grasshopper plugin. This right side here is kind of like this programmatic approach to designing the facade, and it's an approach that is decided by rules and principles. So the principles of this facade design was these sectional kind of curves that make up the facade. Now this part of the facade is decided with 5 of those sections. So there's rule number 1, and all of that information is then kind of cut up, divided into little louvers, and then the louvers all have a dimension and an orientation. So those are all the rules, the parameters for the design.
So would you be 3D modeling this through Rhino, or would
So
you?
you're not doing any 3D modeling. You're kind of, so I think the only thing that's 3D modeled is this line, which anybody can do. Well, not anyone, but you know, it's
2D
very,
model.
yeah, it was 2D modeled. 5 lines like projected in the 3rd dimension. So that was the first part of this little bit, and then everything thereafter is algorithmically generated. That means there's little pieces of formulas in all of these nodes that say, in line number 1, divided into 100 sections. Do the same thing for the next 5. Connect all the points with a line. Extrude that line into a surface. Extrude that surface into a 3D form. And then change the size of that extrusion, and then you have this dynamic form being programmed. So the cool thing about that is the designer can then go back and change this original parameter, which was the curve. Like you can push it here, you can make it longer, maybe the whole thing becomes bigger, maybe I add more sections. And when you do that, all the steps thereafter get automatically updated. So you're kind of like making the computer do the bulk of the work for you. And it's a really awesome design tool too, because you think kind of logically through a problem. And you can enter dimensions like, I know the biggest piece of wood I can get is like, I don't know, is 16 inches wide. So that's a parameter I could put into my program, and I'll never design anything outside of that. So there's like really amazing constraints. Maybe there's a constraint here for the density of the perforation that is directly related to a south-facing facade versus a north-facing facade. South-facing has lots of sun, north-facing has no sun. So you want the opening to be really wide on the north side. So there's like really logical parameters that designers use all the time to make their products and buildings
So this is
that
just
you can input right here, and then this kind of like gets automatically generated.
so it would just reduce like the ridiculous amount of tediousness that would go into making this.
Yeah, absolutely. But also, sometimes surprising things happen that you didn't plan. And I think like a lot of old school designers will be like, whoa, this is crazy. Like you're forfeiting your right as a designer to like make decisions. But in a way though, it like elevates what you can do. Because I'm sure you really feel the same.
I think it
She's
like
just, like,
elevates the
squirting
designer
her
to
seat
like
with
like an
the
engineering, almost like the optimization side of like engineering, especially when you add like the number sliders in there, 'cause you can see visually, or like you can see like what's happening in real time and then bake it instead of like, and then when you take it to the client, they're like, oh, like, what is that? You can let them play with the number sliders until they're happy.
Yeah, for sure. So there's like really practical things like saving time for revisions, real-time modifications that your boss doesn't have to wait for you to update, they'll just see it in real time. Those are all really great. I think there's this like higher level creativity aspect to this that I think is even more exciting because you know, when you're designing, say, when you're an artist, you can kind of do it for yourself or do it for a social cause, you know, whatever you choose. But when you're a designer, there's an end user usually. And that end user is very seldomly you yourself. So I find that like externalizing some of those design decisions into a system like this will allow you to really make sure you're catering to somebody else or the end user. And if there's parameters like analytics from the web that you can scrape, that you can insert into this program right here and make sure that the customer's needs actually match what you're designing, like that's gold. Not only does it make your life easier, you can actually do something that's way more useful to people.
In software, we call this modularization.
Yeah.
So these are all like small modules.
Yes.
We are basically calling these modules. So even in kitchen, right? Like there was a like big trend of modular kitchen, because it is very easy to open, easy to like assemble, easy to break.
Yes.
I was using an open source 3D software called Blender that used, I mean I only discovered it later on, but it used a similar thing that became, like you could go into so much detail with customization, almost right down to like what the texture would look like and feel like and things like that stuff.
Yeah, Blender is a great tool.
Yeah, on that note, like, do you think this is a more powerful combination than say anything SolidWorks or Autodesk products might have, or
Depends on what you're doing. Always will depend on what you're actually doing. We choose Rhino because there's a lot of reasons. I think it depends on the scale, the types of geometries that you're trying to create, the level of flexibility you want. SolidWorks is an amazing piece of software, but I would definitely say it's more geared towards like creating parts, very kind of precision made, like engineering components. But if I'm hoping to do something more ephemeral, something a little bit more like sweeping and more artistic, I tend to go with Rhino. And it's a very lightweight piece of software. It won't weigh down your computer either. And the great thing is it has the Grasshopper plugin, which is by no means the only thing, but I found that to be kind of beginner friendly.
that combination makes
Yeah.
it more like SolidWorks, or gives you a different
Yeah,
kind of
yeah, I know
tool.
SolidWorks is parametric,
Yeah.
but it's parametric in this really precision, like functional way, whereas this could be a lot more freeing, like processing or something like that. So the cool thing about this though is, you know, it's not speculative. In my industry, CAD and everything is a standard for actually creating drawings for contractors to build your thing. So in that sense, somebody might say, well, this is like really, you know, it's really cool and beautiful, but like, is a contractor going to be able to build this? Because every single piece of louver on this thing is unique. But the cool thing is, with that particular project, that entire facade was fed into this like super archaic like construction document software called Revit. It's a CAD product as well. And this thing was actually, you know, built. So all of these pieces of wood are glulam. Glulam is engineered wood. And every single component is unique. So if you've ever been to like home hardware like Home Depot, like you know wood comes in dimensional lumber. Like there's no way you're going to use that for this. So normally a contractor will be like, this is going to be so expensive and it's actually not possible to do something like this, so unique and so not modularized in terms of like the actual raw materials. So how you actually create something like this is with a CNC. So a CNC mill is basically a robotic arm. You guys know what that kind of looks like, right?
Yeah.
But at the end of the robotic arm, there's like a drill, like a Dremel almost, but pretty powerful Dremel. And you can input a 3D form into a CAD program, and that little robot arm is going to use a tiny little drill bit to like sculpt out like a big block of wood. You can do this with foam, you can do this with metal. It's a way to create unique parts, and this whole process is done kind of in a lights out manufacturing format where this machine just goes like 24/7 and nobody is there to operate it. It just kind of does the work. So right now you're seeing it, so that it does like rough passes over form to get the general shape, and then a smaller bit will go around and mill out the form. So that's how every single little piece of that building was created. Has a big bill at the end of it, but you know what's cool, like, is that it exists, and that somebody ended up saying, okay, this is a good business case, I'm gonna make it. So this is like evidence that, you know, it's not speculative, it's not someone's theoretical thing, like this made financial sense to someone to do. It's expensive, it doesn't happen all the time, but it's real.
Is this what they did with the UGO extension as well?
Yeah, many parts of it was CNC'd. The glass is very different, right? So the glass is going to be mass produced in some way or actually done with cheap labor overseas. I'm going to bet that's how they got that glass. That building didn't come up for a long time because all the glass in the world was being made in China, and they just had so much work that there was just no glass for anyone or no steel for anyone for like a few years. Yeah, so this process is really applicable for wood in the construction business. Doing this with like curvy glass and stuff like that, there's other processes, but similar computer-aided processes.
What type of building is it? What is it being used?
Oh, it's a stadium. So this is the Lansdowne Stadium in Ottawa. It's right by the river. Here's a photo of it being constructed. And then like, and then this is like near completion. Now it's complete and it's there.
That's crazy. That's crazy.
All wood?
Yeah, all glulam wood, and then there's like a really boring stadium, like the rink. They could only do something cool with like that part, and that's it. But yeah, so it was cool because, you know, like the speculative thing that we were working on in school, like kind of came full force, and we get to see this like professionally and know that this kind of thing is on the rise, happening more and more often. But the thing about that industry that I was in was, well, this project comes like once every 10 years. And it's not all the time that it's happening. And the big part of it is, you know, buildings are just so big, and making those kinds of changes and strides will take a long time. So in our free time, we thought, well, what if we use some of those same ideas and applied it to something smaller, something that would be way faster to create. So the great thing about rapid prototyping is that it's scalable. So from buildings, we can actually shrink down that entire process to produce things that are small and fit into our daily lives. So once we found out that, you know, all of this equipment was accessible and we could actually, say, purchase a 3D printer for like $2,000 ourselves and operate it ourselves, we thought, okay, we should really do something here. So we decided to actually think about what would be a small item that would, you know, merit this kind of design experimentation, and something small that would be like really fast to print and cheap to print, and something that, you know, we kind of could do something with. So we actually chose jewelry for that reason. And we use Rhino as well so the same software that we were using, you know, because, you know, it was something we were familiar with, but also it's another scalable part. Like, you can use all the same tools to create a totally different scale of product. So you can imagine the rules in this case, which is, it's a very simple, so the earrings a specific length, and there's 3 different shapes we're playing with, and we're going to randomize the way that they're located and the orientation that they're facing. It's a very simple little program. And we kind of use that to our advantage. Because we were 3D printing the jewelry, and because we were generating it with an algorithm, we thought, wouldn't it be great if we could sell a unique design to every single person who purchased the product. So we were trying to get this mass customization thing going, kind of manually, but basically we set the program to generate like hundreds and hundreds and hundreds of designs. And we'd go in and just kind of pick the ones we thought were, pretty to look at, because we didn't write a program for that yet, but it's possible. And then we actually used, programming language to even create like the imagery that we use to put it online. So we got like a little Shopify thing going, and we decided to create the designs. Maybe you can look at this one here. So for those of you who haven't seen laser sintering 3D printing before, this is how it's done. So we use this type of 3D printing to create the jewelry eventually. But basically it's layers of powder that gets laid down by the machine, and a laser goes around and sinters the part, like the area where your part lives, and then a new layer of powder goes over, and then that part gets sintered, layer number 2 gets sintered to layer number 1, and then eventually you have a 3D form that's kind of embedded in powder.
Is it metal, this one, or?
This one is metal. I'm not wearing my thing.
Yeah.
But yeah, this picture you're looking at is metal, but the actual pieces that you saw in the previous slide is nylon.
Okay.
So it's a type of
And
plastic.
it's sintered nylon as well.
Sintered nylon.
Is it sintered metal as well?
Yeah, there's sintered metal as well.
Is
We
it the
decided
same
not to go there.
Okay, what is sintered? It's like fusing.
So the laser that I was talking about that was going around, it melts powdered metal.
Oh.
And when you melt it, the powder becomes liquid and then it fuses to itself. So that's sintered. It's kind of like welding.
Welding.
Oh, okay. So did you got a sales picture for
No.
$2,000? Yeah.
No, we did not.
Yeah.
So we used,
Yeah, I was like,
no, so those are like
Yes.
$500,000 if you were
Yeah.
thinking about it.
Oh.
Yeah.
So we kind of ramped up. We first did a collection that was completely FDM 3D printed on a MakerBot, on our
Oh,
MakerBot,
okay.
in our dining room table.
Okay.
Like we did it when we went off, like when I finished work, we would like pre-print. And we used all the money we made from that to outsource 3D printing for this collection.
To Anubis?
Yes, you can use Anubis, you can use Shapeways, you can use any third-party service out there. It's a little bit more expensive, but because we did the first collection on our own printer, it financed being able to do that, and just the little bit of risk that was required to do that.
How quick is sintering like compared to FDM?
All terribly slow. Just like all kinds of 3D printing is so slow. But the cool thing is, it's faster than not doing it at all. Like that's the thing, because you like wouldn't be able to do this otherwise. You can't afford to get a mold made. Like you at least have to be spending $50,000 to make a mold for one product. And most likely, that first thing you try to do is going to fail. Like that's what we learned. No matter how smart you are, or how careful you are, or how much research you do, your first product is most likely going to fail. So what's the safest way to do it? Like to try doing it like this, incrementally.
we fail in terms of reaching the market, getting it right, or
Making
meeting
a
the
profit.
demand. Yeah, oh, yeah.
Yes.
Did you fill up an entire, the blocks or whatever, like when they're printed? Like, did you fill up an entire
No,
thing
you
with
don't
your?
have to. No, you don't have to. You can pay Shapeways more to do like one-offs, for example, but it takes forever. I
Yeah.
could tell you more about like
Yeah.
logistics,
Okay.
but we help people do that now.
Okay.
You don't have to fill up a whole batch.
Okay.
Okay, so like the great thing was we were able to do it, that like with no capital. I think we spent the $2,000 on our first machine, and we did it in our off hours, and then it got us to a point where we could actually have something to put out there. So the next kind of really important thing was the sustainability factor of the way that we started our business. Kind of by accident, but we did it really sustainably. And this is how we did it. Instead of selling stock or inventory, we sold digital renderings. We didn't make anything until we made $1. So that was the cool thing. We used 3D printing to help us prototype and come up with something good, something that I thought at least was like okay and I could put it out there. But what we did was we filled our store with renderings of our products. And you can make some pretty sweet renderings. Like some of the default settings in some of those programs like Blender is pretty good. And these days people are really used to seeing that kind of imagery too. So what we did was we would like test out ideas before we even invested anything or any time. So we put renders on our site. It was useful for figuring out if people even liked it. If they like the triangle one over the circular one, or if they like the black and white collection versus the color one, like really micro decisions that I think designers just go, oh, I like the black and white one, I'm all about black and white. But what if the market doesn't want it? Or maybe what if you can have more customers if you had like this psychedelic collection and you branded it for those people. So those were the decisions that we came to actually be able to make very quickly, but rationally, according to the market demand. And then of course, like we wouldn't actually invest in producing it or shipping it out if like we didn't make an order. So we kept no inventory and we were able to sell at something that people actually wanted, and we only needed to put in the capital to do it until we made a sale.
So what's your point in selling this type of product? What is your product about?
So in this particular case, it
Yeah.
was jewelry. So we were selling fashion jewelry.
To like high-end like Dior and all that stuff?
To where?
Like high-end fashion?
Well, at the time, we weren't sure who our market was. And we put it out online, and we were really lucky because 3D printing was so hot. So this was like maybe 4 years ago, 3 years ago,
Yeah.
all over the media. And we were pretty, like the next thing I'm going to talk about is DIY PR. PR was like a huge part of why we even got people to visit our site. Otherwise, nobody would even come. Even if you did good work and even if people wanted to buy it, if you don't have distribution, then you can't make any sales. But we were lucky enough to have people be interested. It was novel enough, and we were risk adverse in doing it, that it became like a sustainable business model.
Okay.
What is your core question?
So my core question is, what was the cash flow? How much did you guys make?
We made positive cash flow.
Okay.
We financed renting space in the city of Toronto in like Queen and Spadina area. We bought our own laser cutters. We bought our own 3D printers. I quit my full-time job and I have like a full-time salary from my business.
Wow.
So like those all sound like it sounds like nothing when like you read about people like raising millions, but we have 100% of our business still belongs to us, right? So that's like a really big deal. But I can't tell you how long. Like it took us a long time to like be brave enough to quit our full-time jobs, for example. To be brave enough to be like, hey, like I think next month looks good, but you know, like I bet next year is gonna look good. That's really hard to say. I could get to that like a little bit later, but the jewelry was kind of like our micro business that allowed us to get some capital to invest in our own equipment. That was like the piece we were kind of missing, because eventually we wanted to use like better processes. And the thing about being small is that you can't like call a CNC shop and be like, hey, can I make like one thing? Like they'll not answer you. They will not do it for you because they want an order for 1,000 things and you don't have that yet. So we felt like, okay, as an independent designer wanting to make things ourselves, either we invest in our own equipment and try to do that for other people like us, or I got to get tons of capital before I could like do that. So there's this other scale.
Like,
No, we have no investors. We never looked. Yeah, we were really, really concerned with sales, so we focused on that completely. Yeah, we weren't ready to sell off pieces of our business yet because I think we're still looking for the right product.
Yeah.
Like I don't really want to give it away until I know what I'm doing, and because we've been working on this for a while, we actually know how to gain customers and we already have customers. Like the longer you can wait for that, actually, it's good. When you can walk, when you can walk into like a meeting with an investor and be like, I already have customers, and they already pay me, and here are my financials, we make a profit.
Yeah.
That means they can't take 25% of your company for like just a measly few million. Like, you know, they'll take a lot because they have to make sure their money is worthwhile, right?
Yeah.
So,
And you don't want to get sued by like certain like partnership with them?
That's harder to say, like, yeah, I mean, you can be really conservative going into it, but yeah, I think that like the startup mentality of like raising lots of money before you have any customers is a little bit twisted, especially with a physical product. It takes a lot of money to make physical products. I think that's the difference between a software company and a hardware company.
So how did you figure out costs for this? So you have to find out unit cost, right? Like for like whatever getting printed or manufacturing this jewelry part, and then you make certain margin after selling. So you get the order before from people, but then you must be like quoting. Okay, I will charge you $20 for this.
Yeah.
How do you know the basic cost for this? Like,
You could do the same thing like I was talking about, doing A/B tests. Like you're nobody, like you don't have a lot of people watching you. You can change your price every single day, every single week. Start high, and if nobody buys, drop it a little. Change that image, do something else. Put it on Twitter instead of Instagram. And like you can literally just treat it like an experiment. Don't think that what you do for the first time is gonna stick. It usually won't. So you'll have to like try all kinds of things. You know what, another thing we did was, we weren't getting a lot of traction for a few weeks, and I took my laptop, we went into Starbucks, and I bought like 10 people coffee in exchange for 2 minutes of their time, and I got them to sit down with me, and I watched them use our website. And I asked them 3 questions. Would you buy this? Yes or no, like at this, or how likely are you to buy this, 1 to 10? And you can decide for yourself. If they say under 9, then they're probably not gonna buy it. And then you can know. And that's like real like
Hardcore customer.
like you can get.
You did good.
It was a pain in the ass. I really don't want to do that. Like going to Starbucks and doing that is horrifying. Like I don't know anyone who would enjoy that process. But you can either like get some sales or no.
Have you guys had like any interaction with like other design companies? Because like looking at your work, it's a little bit like what Umbra does as well, like but more jewelry wise, I guess.
Okay, so Umbra is very different. Like they're our clients right now, and they have a team of designers, really talented folks. Like I'm sure like a lot of people from OCADU would